Once again, we're with the Advanced Functions and Modeling Indicators. This time we're working with Standard 2.02 and we're doing Example 1. Now, the AFM Indicators is a document released by the North Carolina Department of Public Instruction, and the State Department says that if students can answer these questions, then they are definitely well prepared for their North Carolina final exam. So let's get right into it. This particular question or standard is talking about piecewise functions. So it says, given the following piecewise function, h of x is equal to x squared when x is between -3 and +3, and h of x is equal to 2 minus x when x is greater than or equal to 3 but less than 7. So let's go ahead, and the first thing I want to do with this is I want to partition off this graph because it's a piecewise function. So I want to go from -3, I'm going to put a little line, from -3 up to +3. I'm going to put a partition. And then from +3 to 7, I'm going to put I'm going to put another partition. Okay, so these partitions you'll see is where the piecewise function separates. So from -3 to +3, the graph is equal to x squared. Now if we go ahead and do a t-chart over here, so we can say x and then x squared. Or actually, we could say, no, let's do it like this. Let's do x, and then let's see h of x, okay? So I'm going to do -3, -1, 0, and +3. I'm going to do those three values. So if I have -3 squared, then I get 9. Okay, and if I have -1 squared, I get +1. 0 squared gives me 0, and 3 squared gives me 9. So that leads to the ordered pairs -3, 9, -1, 1, 0, 0, and 3, 9. So that's for this first part of the function, okay? So we can have x, and then h of x is the same thing as x squared. So that's why I have these values squared. Well, if we do another table of values down here for the second part of it, so you have x, and then we have h of x, and let's just say equals 2 minus x, okay? So from here, I want to go with +3 again. I want to go with 5, and let's go 7, okay? So if I have 2 minus 3, I get -1. 2 minus 5, I get -3. And 2 minus 7, I get -5. So over here, I'm left with the ordered pair 3, -1. Then I have 5, -3. And then let's put the last one down here, 7, -5. I'm sorry that's over there in the corner, but we can actually move this. Let's move that over there. So let's take this ordered pair and let's give him some space. Yep, there we go. All right. So now that we have our ordered pairs, we're simply going to graph these ordered pairs. And once we graph these ordered pairs, you'll see how the piecewise function works. So starting here from -3, 9. Now notice it says -3 is less than or equal to. So -3, and I go up 9. Let's use a different color. Let's go with blue. -3 and 9. All right, and that is a closed circle because it's got the equal to part right there. And then we have -1. So -1, 1, 0, 0, and 3, line. But notice this 3 is going to be an open circle because its x is less than 3. So we're going to keep an open circle because it does not count there. So here, let's go ahead and try our best to connect these. We know it's a parabola, so it looks about like that. Okay. Let's try to correct that last little part. So make that look a little better. And then now we're going to take a different color to graph the second part. Let's go with red on this part. So I have 3, -1. Okay. Now notice this 3 is included. So 3, -1. So this is going to be a closed circle. Okay. So the fact that this is on 3 and it's open, and the fact that this is on 3 and it's closed, you'll see what that means in a different. Then we have in a minute. So we have 5, -3. Okay, and then we have 7 and -5. And notice this one is open circle because up here x is less than 7. So we can connect those 3 as best as we can. They are linear. So this is a line. It's not the straightest line, but it's a line. Okay, so this is a piecewise function. So notice this is what our graph looks like. Okay. Notice it becomes continuous because this circle is closed. So this value of 3 is what we count. This value of 3 is not what we count. Okay, now it says, so we've sketched the graph and it says state the domain and range using interval notation. Okay, so the domain basically when from -3 to +3, and this is going to be there. Okay, and actually this domain actually it continues on technically all the way up to +7. So let's go back. Let's go back a little bit. All right, so the x values go from -3 all the way to +7, but 7 is not inclusive. Okay, here's my smallest value of x, so -3, and it goes all the way up to +7, but we have this parentheses there because that tells us that the +7 is not included. And then our range, let's look at our y value. So our smallest y value is down here, which is -5. That's not inclusive. So we have -5, comma, and we go all the way up to +9, which this 9 is not included, but this one is. So we can include that 9. So that's our domain. That's our range. All we did was we look at our smallest x value and our largest x value. Since this x is not inclusive, we have to put that parentheses right there. And then we go from our smallest y value to our largest y value. Now part B, so this is part A right here. Okay, also including the graph. It says, what is h of 3? And how do you know which function to use? So when h is equal to 3, this is x is less than 3. So we can't use x squared for our function. We must use this one because it says 3 is less than or equal to x. Okay, so what is h of 3? But really, if we just go to the graph when x equals 3, we go to the closed value. Okay, so the value that has a closed circle. So B, h of 3 is equal to -1. Okay, and how can we prove that? If we plug it into this function, 2 minus 3, we get -1. So this proves algebraically that h of 3 is equal to -1 because we have to use the second function. But also if we go to the graph where x equals 3, we don't want to use this value because it has an open circle. We use this value because the 3 is included. And that's how we know which function to use, because this right here has the equal to sign. So this is piecewise functions.